Welcome to Lavanya's computer classes. In this video, I will explain serializability. Serializability in DBMS. In the previous video, I will already kept one video like what is scheduling and types of scheduling. In the scheduling, there are two types of schedulings are there. One is the parallel scheduling and the second one is the serial scheduling. So, in the serial scheduling means serially executed, transactions are executed one after another. In the non-serial execution means transactions are executed simultaneously, concurrently. So, in this now we will go for explanation of what is serializability. So, what is the serializability means definition is a schedule is serialized if it is equivalent to a serial schedule. First of all, we take any non-serial schedule. If any non-serial schedule is equivalent to a serial schedule, that is called as serializable. Serialized, or a concurrent schedule must ensure that it is same as serial schedule. So, any parallel schedule is possible to convert into serial schedule is called as serializability. Now, we will explain some more example. There is a schedule S. The schedule S contains two transactions T1 and T2. First, we complete transaction read operation. We are doing the operations like this, read A, write A, and again read A, write A. So, if we see like this, then we can easily understand this is an example for serial schedule. Serial schedule means one after another. First, we execute the transactions T1, then completed. After completion of T1, then start your T2. So, like this. So, this is the first T1, then T2, one after another. That's what is called as serial schedule. Now, we draw a graph. What is that graph mean? That is called as precedence graph. So, precedence graph, already we know what is a graph. Graph means it's a collection of edges and nodes. So, in these transactions, what are the nodes are there means how many transactions we have, those are treated as vertices, nodes. So, here how many transactions are there? Two transactions. So, T1 is considered as one node and T2 is considered as another node. So, in this, first which transaction is completed first, which transaction started and completed means T1, then T2. So, we draw a edge. Edge is the execution of the transactions, order of execution of the transactions. In this example, first we execute a transaction T1, then T2. So, draw a graph like this, directed graph. So, T1, T2, two transactions. Two transactions are considered as nodes and edge. Directed edge, it is a directed graph. First T1, then T2. So, this is the precedence graph of serial schedule. If you write like another example, like T1, T2, first we write read operation, write operation, then again read operation, write operation. So, this is also an example of serial schedule, because in this first we execute the transaction T2, then transaction T1. So, one after another. So, this is also an example of serial schedule. For this example, draw a graph, precedence graph. So, how many nodes we require means depends upon the transactions. So, how many transactions we have? There are two transactions are there. So, consider two nodes, T1, T2 are the two nodes. Now, we create a edge. How we create edge means edge means the transaction, order of transaction. So, here first order is T2. T2 executed, then T1. So, draw a edge like this, T2 to T1. So, this is the one precedence graph for example of serial scheduling. This is also one more precedence graph for this is also a serial scheduling. But here first T1 is completed, then T2. In this example, first T2 is completed, T1. So, these are the serial scheduling. Now, in this serial schedule, it is no problem. Now, we go for non-serial schedule. Now, I will give one more example. Like this is the schedule S. Here, two transactions are there, T1 and T2. In this, I will write some example. Some transactions, execution of order RA. Then we go for RA, WA, then WA. So, here these are also two transactions are there, one schedule S. There are two transactions are there, R1 and T1 and T2. So, these are the operations RA, again RA, WA. So, here see, just check it. It is a serial schedule or parallel schedule, non-serial schedule. It is an example of non-serial schedule because first we started the transaction T1, one operation performed on the T1, then we jump it to T2. Here in this T2, we are applying two operations and again coming to T1. So like this. So that means transactions are executed parallelly. That's what is called as non-serial scheduling. Now we draw a graph, precedence graph. So how many transactions, how many nodes we require depends upon the number of transactions, T1 and then T2. Now we draw a edges. First where we started? We are started in T1. So T1 to T2. After T2 is completed, again going back to T1. So like this. So this is the precedence graph. If we see this precedence graph, T1 to T2, T2 to T1, here cycle is formed. Cycle or loop is formed. Whenever any precedence graph is following some cycle or loop, that is called as parallel scheduling, non-serial scheduling. For looking, it is a non-serial scheduling. Now we find out this parallel scheduling or non-serial scheduling is possible to, equivalent to, write like a serial schedule, that is called as serializability. In simple words, any parallel schedule is possible to convert it into serial schedule. Any possibility is there, that is explained by the serializability. For checking serializability, there are two methods are there. One is the view serializability, and the second one is conflict serializability. For find out, is it possible to convert any non-serial scheduling to serializability, serial schedule, that is called as serializability. How many methods do have? There are two methods are there. One is the view serializability, second one is the conflict serializability. Now I will explain conflict serializability.